morning, grade 8s, and welcome to lesson number 5. So we are going to start with particle model of matter on page 89, but that's just a summary, so we're going to start on page 90. The particle model of matter. So if you go to page 90 and 91, there's all the ways particles are found. Now, particles are so small that even with a microscope we can't see them. But all matter is made up of particles. Particles are constantly moving, which can be seen by those little lines. They are constantly, like in a solid, they'll be vibrating in space. It's just on vibrating in place. And then if you add fire, this makes the movement increase. Fire, heat. So if you add heat to a matter, the particles within that matter will speed up. They also have spaces between them. These spaces are empty and it's not even air in between them. But they also have forces of attraction between each particle. So they're away from each other, but there's this force keeping them together in that pattern in a solid. And with the more energy, that force of attraction becomes weaker and the pattern kind of goes away slowly. And that's how we get to our different phases, which we'll be looking at on page 92. So we have solid, liquid, and gas. So these are three forms. These are called three forms. These three forms are called states of matter. So the particle model of matter explains the different states of matter in a solid. So how we know what different stage it's in is what the particles are doing. So in a solid, the particles, you can see on page 93, are packed closely together and arranged in an organized pattern. They vibrate in a fixed position, they have strong forces between them, and they have very small spaces. Now look at the difference in a liquid. They are closely together but less arranged, and they are loosely arranged compared to a solid. They move slightly faster. They are not held by strong forces. They still have small spaces between them, but they are larger than in a solid. Then in a gas, so we've got that in-between stage, which is our liquid. Now in a gas, there's no arrangements. They move very quickly. They have so much energy that they move freely and fill a space. So there's no force of attraction. And they have very large spaces in between them. So your solid is very strict, your gas is very free, and the liquid is almost like that middle stage of a bit of both. So on page 93, you can see diagram, and on your notes, diagrams of ice, liquid, and gas, which is water is always a good example because it can be a solid, liquid, and gas. Because you can freeze it into ice, at liquid form it's water, and gas it's condensates. Okay, so diffusion. The particle model of matter explains diffusion. Diffusion is a process in which the particles in liquids and gases move from one place where there are many particles, so a high concentration, to places where there are fewer particles. An example of this is perfume. So diffusion. Now, if I were in class right now, I would show you. So I spray my perfume on me. Now this is high concentration. All the perfume molecules are here. But then slowly it will reach all parts of the classroom, because perfume is obviously a gas. The gas molecules will mix with the air molecules and reach all over the classroom. So if Caitlin's in the front and Daniel's in the back, Daniel will smell it last and Caitlin will get it almost immediately if I'm standing next to her. That's diffusion. It starts off as a high concentration and diffuses into a low concentration. So think of it like mist, creepy mist that starts all here and then its fingers come out for you and it diffuses into the land. Okay. Compare rates of diffusion in liquid and gases. Different substances diffuse at different speeds or rates, which makes sense. Different substances, they have different characteristics, they'll diffuse differently. Diffusion takes place faster in gases than in liquids. So, in figure 12 on page 94, you can see that all the little red balls stay here and then the orange ones are here. So these, let's say, is your perfume and this is your air. And then slowly the air and the perfume mix till it looks kind of not equal. The ratio is not equal, but they're dispersed evenly. So we'll do change of state in our next lesson, but for now, that is all. I know it was a short lesson, but I think you guys will understand this really well. And if you don't, ask me questions. I'll send notes with this. And then you've got your activities to do, which will be sent with the lesson. And then otherwise, have an amazing day and work hard like you always do. Thank you.